Welcome to Pioneer's Knowledge Hub.
Have you ever wondered why most of our devices still need to be plugged in this day and age? It's a question that may have crossed your mind as you untangle yet another knot of charging cables. The reality is, our world runs on electricity, but the majority of that power is still delivered through physical connections. The cables, plugs, and wires that clutter our homes and offices are a testament to the ubiquity of wired electricity transmission. But what if there was another way? What if we could harness the power of electricity without the need for a physical connection? Enter the concept of wireless electricity transmission, a revolutionary technology that promises to cut the cord and redefine how we power our devices. And that, my friends, is what we're going to delve into in this video. We'll explore the ins and outs of this technology, its potential benefits and drawbacks, and what it might mean for our future. In a world of wireless communication, isn't it time our power supply followed suit? To understand wireless electricity, we first need to understand how electricity works. Simply put, electricity is the flow of electrons, which are tiny particles that whiz around the nucleus of an atom. When these electrons move from one place to another, they create an electrical current. This is the energy that powers your television, charges your phone, and keeps your refrigerator cold. Normally, this electric current is transmitted via wires. The electrons move along the wire, carrying the energy from the power station to your home. This is why we have a maze of power lines crisscrossing our cities and countryside, all carrying electricity to where it's needed. But what if we could remove these wires? What if we could transmit electricity through the air, just like we do with radio and television signals? Well, that's the basic idea behind wireless electricity. In wireless electricity transmission, the electric current is first converted into another form of energy that can travel through the air. This could be microwaves, which are the same waves used in your microwave oven, or it could be radio waves, which are used to transmit radio and television signals. Once the electricity has been converted into microwaves or radio waves, it's beamed out through the air. It could be sent from a power station to a home, or from a charging pad to a smartphone. And just like a radio picking up a signal, a receiver at the other end catches these waves. But instead of converting the waves into sound or pictures, as a radio or television does, the receiver converts them back into electricity. This electricity can then be used to power a device, charge a battery, or do anything else that normal, wired electricity can do. It's a fascinating process and one that could revolutionize the way we use and think about electricity. Just imagine no more tangled cords or hunting for outlets. Just pure, clean, wireless power. Scene script. Like any technology, wireless electricity has its pros and cons. Diving into the positives first, the benefits of wireless electricity are quite enticing. The convenience factor is undeniable. Imagine a world where you no longer have to fumble around with cords, or search for an outlet to charge your phone or laptop. You simply place your device within range of a wireless power source, and voila, it begins to charge. This is the dream that wireless electricity could make a reality. Moreover, wireless electricity has the potential to contribute to cleaner energy solutions. With the ability to transmit power over distances, we could theoretically harness energy from renewable sources located far from urban centers. For instance, a solar farm in a desert could wirelessly transmit its collected energy to a bustling city miles away, reducing reliance on fossil fuels and cutting down on the carbon emissions associated with traditional electricity transmission. However, as with any technology in its developmental stages, there are challenges and drawbacks to consider. Energy efficiency is one such issue. Current wireless power transfer methods can experience significant energy loss during transmission, making it less efficient than traditional wired electricity. Cost is another concern. The infrastructure required to implement wireless electricity on a large scale could be expensive, at least initially. However, like with many technologies, these costs could decrease over time as the technology matures and economies of scale kick in. Additionally, there are potential health risks to consider. While the World Health Organization and other bodies have determined that low-frequency electromagnetic fields associated with wireless power are generally safe, more research is needed to fully understand the long-term effects of exposure. It's important to note that these challenges are not insurmountable. They represent areas for continued research and improvement, and many scientists and engineers are dedicating their careers to addressing these very issues. So while it might not be perfect, wireless electricity holds a lot of promise for the future. The potential for convenience. cleaner energy, and a cord-free world are all compelling reasons to keep our eyes on the horizon of this exciting technology. So, what does the future hold for wireless electricity? Imagine a world where your electric car charges itself while parked on the driveway, or your smartphone powers up simply by being in your pocket. This is not science fiction, but the future of wireless electricity, a realm of possibilities that are currently being explored and developed. The advancements in wireless electricity transmission are truly impressive. Researchers around the globe are working tirelessly to bring this technology into the mainstream. One of the most promising developments is the use of resonant inductive coupling, a technology that allows electricity to be transmitted over short distances without the need for a physical connection. This could revolutionize the way we charge our devices, from smartphones to electric cars and even drones. Now let's talk about specific applications. Take electric vehicles, for example. The cumbersome process of plugging in your vehicle for hours could soon be replaced by wireless charging pads embedded in parking spaces. Just park your car, and it charges. Or consider remote areas where traditional power lines are impractical. Wireless electricity could bring power to these places, opening up new opportunities for development and growth. The potential for this technology is enormous. It could fundamentally change how we use and think about power. No more tangled cords, no more searching for an outlet when your battery is low. Instead, power could be as ubiquitous as the air we breathe. But as with any new technology, there are challenges to overcome. We need to ensure that wireless electricity is safe, efficient, and affordable. But the progress we've seen so far gives us reasons to be optimistic. So next time you're fumbling with a cord, remember, a wireless future might be closer than you think. The days of wrestling with tangled wires and hunting for power outlets could soon be a thing of the past. The future of wireless electricity is not just about convenience, it's about creating a world where power is available to everyone everywhere all the time. So are you ready for a wire-free world?
Please do like, share and subscribe to my channel. Thanks for watching.